Day 445 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1695, maximum erasure value. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array of positive integers nums and want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to the sum of its elements. Return the maximum score you can get by erasing exactly one subarray. An array B is called to be a subarray of A if it forms a contiguous subsequence of A, that is, if it is equal to A of L plus A of L plus 1 all the way up to A of R for sum L and R. So I hope that makes sense to y'all. Right now we're dealing with subarrays, which is different than a subsequence, right? So a subarray is a contiguous, or it's different than a non-contiguous subsequence. A subarray is a contiguous subsequence, and that means the numbers have to be, or the elements need to be concurrent or right next to each other like this. This would be a subarray. This would be a subarray. This might be a subarray, but that's the contiguous part. So a non-contiguous subsequence is where you might be able to delete an element. This is not one of those problems where we can delete an element, right? So we can't delete this 2 or delete this 5 and just return the 4, 4, 6, right? It has to be in order and it has to be contiguous, ongoing. The numbers need to be concurrent and next to each other, right? So if this is A of L, this would be A of L plus 1. This would be A of L plus 2, and so on and so on. We can't just skip around numbers within the array like we would when we're dealing with a non-contiguous subsequence. So that's the difference between a subarray and a non-contiguous subsequence that is going to be important to understand while we're writing this code and going through these examples. So now that we understand the problem, y'all, let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 4, 2, 4, 5, and 6. Our output is 17. Explanation says the optimal subarray here is 2, 4, 5, and 6. So when we add these elements together, we get, so 2 plus 4 is 6. 6 plus 5 is 11. 11 plus 6 will give us 17, which is our output, right? Because we want to return the maximum score. So, and remember, the subarray can only have unique elements, right? We want to erase a subarray containing unique elements. So say we started our subarray here, we would only be able to get this 4 and 2, which would equal 6, right? Because as soon as we get this 4, then we have duplicate 4s. That's not what we want. We can't have any duplicates. We have to have unique elements, meaning they only appear in the subarray one time. So if we started here, we would only get 6, because once we get after this 2, we reach another 4. But if we started here, we could go all the way down to the rest of the array without having any duplicates, which will get us our maximum score, right? Which is what we want. So this will get us 17. If we just did it like this, we only get 6, and we want the maximum score. So we're going to return this subarray, which has a score of 17. So just in case that didn't make sense to y'all, let's take a look at example 2, right? So in example 2, we have our input nums equals an array of integers 5, 2, 1, 2, 5, 2, 1, 2, 5. Explanation is 8. The output is 8. Explanation says the optimal subarray here is 5, 2, 1 or 1, 2, 5. So once again, we could start right here. This would be a subarray. 5 to 1. We have to stop after this 1 because once we get to the 1, if we go to the 2, we can't have two 2's, right? All the elements need to appear only one time for them to be unique. So we'd have to stop right here. Similarly, which is why we can't do this as a subarray, because if we did this, it would have two 2's. But we could do this, which is where the other optimal subarray occurs 1, 2, 5, which either way they both give us the output of 8. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult to understand, as I'm sure you can imagine. So let's get into it. First thing we're going to do is we're going to create a set which is going to store the unique elements currently in our sliding window. So we're going to be, I guess as y'all have figured out by now, we're going to be using a sliding window to solve this problem. So right now we're going to create a set that stores our unique elements. So we can declare a variable called scene. Scene, and we can set that equal to a set of integers. So set less than and greater than, and put the parentheses. So that's going to create our set of integers. Boom. Then we need a left pointer for the sliding window. So we're going to declare a variable called left, set that equal to 0. Then we need a variable to keep track of the running sum of elements in the current window. So we could declare a variable called current sum and set that equal to 0. Boom. Then we need to track the maximum sum of a window with all unique elements. So for that, we can declare a variable called max sum and set that equal to 0 as well. Boom. Now we need to iterate through the array with the right pointer. So we're going to say for right in 0 dot dot less than nums dot count. We're going to open up the brackets. Boom. And if the current number is already in the window, we're going to shrink the window from the left until the duplicate is removed. So we're going to say while scene dot contains, open up the parentheses, nums, open up the parentheses again, right. Oh, sorry, not the parentheses. This should be in the square bracket. Nums square bracket right. Sorry about that, y'all. Then we're going to come outside of the parentheses and we're going to open up the brackets. Then we need to remove the leftmost element from the set. So we could say scene dot remove, open up the parentheses, nums square bracket left. Boom. Then we need to subtract it from the running sum. So to do that, we're going to say current sum minus equals nums square bracket left. Then we're going to move the left pointer forward by coming underneath that and saying left plus equals 1. Boom. Now we need to add the current number to the set after this while loop. So for that, we come outside of the while loop and we can say scene dot insert. We're going to open up the parentheses nums square bracket right. Boom. Then we're going to come underneath that and add it to the running sum. So we're going to say, come underneath this, we're going to say current sum plus equals nums square bracket right. Then we're going to come underneath that and we're going to update our max sum if needed by saying max sum equals max, open up the parentheses, max sum, comma, current sum. And this is going to return whichever one is greater. Max sum, if max sum is greater, then we'll keep max sum. But if the current sum is greater, then we're going to set the current sum as the new max sum. Boom. And then after we go through all that, all we have to do is return the maximum sum that has been found by coming right here and say return max sum. Boom. So that should be all she wrote, y'all. Let's give it a run. Make sure it runs correctly before we submit it. That's the code right there. Boom, let's submit it. Make sure it's accepted after we submit it. Let's see, and look at that, y'all. 58 milliseconds beats 84.62% of users. Not too bad. We could get those numbers up, but that's not too bad, especially with this solution. This is a simple and easy to understand solution that we will all be able to learn from, or should be able to learn from, and use the knowledge we learned in future solutions, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.